So recently I bought this used 2008 Honda Odyssey. This one is the EXL trim. It comes with the VCM engine. What VCM is the variable cylinders management. What system do is basically switch off cylinder as you arrive to save gas. But this system have a design issue and it's caused more harm than help. So let's go for a ride and I can tell you about it more. For the generation of Honda Odyssey, it can have two different kind of engine. The J35A6 found in the EX and the LX model have VTEC system. For the J35A7 engine found in EXL and Touring model, this engine have the VCM system. The difference between VCM and VTEC system is, for VCM, instead of switch to a higher cam profile, is close off both intake and exhaust valve of the engine. This create a vacuum inside the cylinder and this suck up oil from the engine. This causes the spark plug to foul and carbon to build up and can cause engine damage. So to mitigate this issue, there's a kit called VCM muffler that will disable VCM, but it's not ideal. The reason is this kit fooling with the engine coolant temperature sensor, so it make the ECU, the car computer, always think that is below 75 C. So when the engine below 75 C, it doesn't activate the VCM. But now the computer have the wrong reading of the engine temperature. It might not switch up the radiator fan to cool down the engine fast enough, so it can cause overheating. And for warm-up enrichment, now the engine too cold, it might spray more fuel for warm-up. That's not ideal. To really address the issue properly, I think the proper way is to disable VCM at its source. So we need to disable VCM at the ECU. So what we can do is modify the ECU firmware to disable VCM completely. So no matter what the ambient temperature is, the VCM always disabled. You don't need to mess with anything, no need to install any kit or any source. Just need to reprogram your car ECU firmware and turn off VCM. That's what I did, and I can show you how. I could do this on my actual car, but if I make any mistake, I could turn my car into a 2-ton brick sitting in my driveway. So instead, I went on eBay and bought a sacrificial ECU that we can take apart and work on. First problem, getting inside. There's no information about this ECU, and Honda sealed it with this super tough silicone glue that is impossible to take apart. I managed to crack the back cover open, but the PCB is also glued to the front cover. I worry that I might damage the connector, so instead I used a Dremel and I cut a hole in the front cover to expose the microcontroller area. So at the heart of the ECU is used this Renesas HH7058 microcontroller. It's based on the Super H architecture. And so we need to figure out a way to able to read out the firmware from the ECU. And I looked through this datasheet and there's a section called the Advanced User Debugger. This have a RAM modder mode that we can use to read out the internal memory or write to it. So I think we can use this mode to dump out the internal ROM of the ECU. So I trace it out the AUD bus, then I big bang this bus and then extract the internal ROM of the ECU. After that, I end up with a 1 megabyte dump of the ROM memory. Now for the hard part. We load this firmware dump into reverse engineering tool called Ghidra, and this is where I spend 99% of the time in. This isn't anything like a typical program. It's a 1 megabyte binary blob. Imagine a book with no chapter, no page number, and no string of text to search for, except just for a version number. It's just a sea of instruction and lookup table. I spent 2 solid weeks staring at the screen, trying to make sense of the matrix. I even started writing my own emulator for this ECU just to understand it. But the peripheral was so complex, it will probably take me another month to just get a working emulator. I had to find a new direction. So I switched it tactic. If I could not understand the code by reading it, maybe I could by watching it. It was time for some dynamic analysis. My plan was to watch the ECU live memory using the same AUD port that we used to dump the ROM with. While I simulate flipping the VCM pressure switch on and off, I showed a pin on the ECU to ground. And after scanning through the memory, there was a single variable that flipping from 0 to 1 right when the pressure switch activated. That was it. That was the breadcrumb that I needed. That single variable led me to the right function, the exact code block that controlled the entire VCM system. I had it. Now we just need to binary patch the firmware to disable the VCM, recalculate the firmware checksum, then figure out a way to reprogram this modified firmware into the ECU. Okay, so now how do we get the firmware onto the ECU? It's possible to flash the firmware over the CAN bus, and this protocol has been well documented online. But I need something lower level, so in case of a bad firmware flash, I can still recover the ECU. So in this Renaissance chip, there's include a boot mode that you can use to reprogram the internal flash, and this done over UART. You just need to set some bootstrap pin to go into this mode. I connected my UART adapter into the ECU and configured the boot pin to boot into this boot mode. And you can get the flash tool from Renaissance. It's called Flash Development Tool. This tool will allow you to flash the binary into the ECU over serial. So just select the binary file, and here I have the readback verify enable, and we can start the flash programming. This usually take a minute or so. Okay, so it finished flashing. Let's install the new ECU and see if this works. Okay, here's the first start. Oh, it's not good. So this was a failed attempt. The engine didn't start. And you can see from the video, there's a flashing green key icon on the top of the dashboard. This indicates there's an issue with the Immobilizer system and it cannot detect the key. The problem is that we swap out the ECU and now the Immobilizer doesn't recognize it. So we need to find a way to program the Immobilizer system to take the new ECU. To do that, I went to AliExpress and buy the cheap clone version of the Honda HIM tool. This allows us to repair the Immobilizer with the new ECU that we got from eBay. Okay, so I paired the ECU to the Immobilizer and let's try again. Oh, start right up, perfect. Alright, so VCM activate at 75C, so I need to ride around a bit to warm the engine up. I'll come back when and report. Okay, so the eco light still turn on, so that's a bit disappointment. So I diagnosed it into this further, and I probed the backside of the VCM solenoid, the hydraulic valve that control the VCM system, and turned out they don't get turned on anymore. So I think we disabled the right piece of code. Now we just need to figure out how to turn off this light. And to do that, I have this idea where I monitor the CAN bus, then match it up with a recording of the dash to see where the bit gets set, and I can figure out the CAN ID and match it up in GitRA and figure out what code control the LED light. And I found that CAN ID 20C bit number 4 is the one that triggered the eco light. So here's the function I found that broadcast the CAN message, the 20C message that turned on the light. And bit 4 which is this parameter, so I labeled it as parameter VCM eco light. And I follow this, and you can see that this function here. that set this light depend on some condition of, like, depend on one of its temperature and some other condition that I haven't reverse engineered yet. So if the temperature is meet 75 C, then we'll turn out the light along with other condition. So easy patches, we can just change this number to a really high, like 1000 degree, and it would never turn on. Okay, so let's try that and see if that works. I'm happy to report that the eco light never turned on. It's a success, and now we just need to figure out a way to flash the firmware without taking it apart, so everyone can do this in their garage. So I found this talk by Greg Hogan. In this talk, he showed us how to program a Honda ECU over the CAN bus. And this is the website that he made to program a Honda ECU. But this tool required the Panda, which is something that I don't have. But I already have something that can do similar, which is a ESP32 that can plug to an ODB port. So I use that one instead. So I connected the ESP32 to my car ODB2 port and start up socket CAN, and I wrote a quick Python script to program the ECU over the CAN bus. It takes about 2 minutes to finish the programming, but here I speed it up for this video. This is the ODB2 interface that I made. It's based on ESP32 S3. And this can talk J1850 protocol, K-line, CAN bus. And it's also compatible with ELM 327 protocol. So you can use existing tool that made for the ELM AT command. This is my hobby project and still currently under development. Once everything ready, I will release as a open source project. And if you're interested in a early development board, I have some that I can sell for a reasonable price. Is that whatever cost for me to make and some postage. So if you're interested, let me know, and that's it. Thank you.